In this video, I will go over standing waves when both ends are closed. What I drew here on the left is a sinusoidal wave, and even though I stopped my drawing here, since this sinusoidal wave keeps repeating itself over and over, just think of this as repeating over and over again forever. Now what I'm gonna do here on the right side, I'm gonna do the first three harmonics. So what I will draw is the first three harmonics. This is gonna be the first harmonic. Here I'm gonna draw the second harmonic, and here I will draw the third harmonic. Now I want you to think of this as a string that is vibrating, that is moving up and down. Okay, the same thing here. It's the same string essentially. Now I do want to let you know that the length I'm gonna keep, since it's the same string in all cases, I will say the length of this is, I'm gonna call it just L. So the length of the string is L. Okay, I'm not gonna use a specific number. I'm gonna use the symbol uppercase L for the length of the string. Now here is how we need to think about standing waves. As I said, in this particular case, both ends are closed. Now what that means is that this point of the string and this point of the string are never going to move. They are never moving. They are what we call nodes. So that's a node, and this here is a node. Now, for the first harmonic, this is what I need to do. I know that this point is going to be at 0, and this point is going to be at 0. I want to go back and look at my wave, and I will try to take the smallest portion of this, okay, the smallest portion that gives me a wave where both these 2 points are at 0. And if I start from the left, and since I see that here this is at 0, the smallest portion, I'm moving to the right, is if I take this portion of the wave. So this is at 0, this is at 0. If I take this portion of my wave, then I can draw my first harmonic. So I will be stretching it. There we go. Now I took the first part of my wave. Now what I want to show you here, this is the first harmonic. What you will see if you do the experiment and you have a string and you actually see the first harmonic, the first standing wave, the way that the string moves is the following. You will see these 2 points of the string not moving at all, and this point of the string is simply going from here to here, and up and down and up and down. And if you look at this point of the string, it is going all the way to here, and then it's going all the way down, up and down, up and down. But all of these, of course, are happening in such a way that you see the string simply moving up and down. Now, fundamentally, a standing wave is just a superposition, the addition of 2 waves, one moving to the left and one moving to the right. But the result, the addition of those 2 waves, gives you what it seems the standing wave, a wave that is not moving in any direction. Now I'm gonna go back and see, and I'm gonna draw the second harmonic. For the first harmonic, I took the smallest portion of the wave where the two points were at 0. For the second harmonic, I'm gonna take not the smallest section, not the smallest part of the wave, but the next smallest where the two ends are at 0. Okay, remember, these need to be nodes. So this point needs to be a node, this point needs to be a node. This is what it means both ends are closed. So for the first harmonic, I went from here to here, because that's at 0 and that's at 0. But now, since I need to choose the next shortest section, I'm gonna go from here all the way to here. And I'm gonna take that piece and I'm gonna fit it over here. And this gives me the second harmonic. And if I repeat this process for the third harmonic, I need to take the next, the piece that is just larger than what I just took for the second harmonic. For the third harmonic, I'm gonna go from here all the way to here. So, and I'm gonna fit that here. Okay, so my drawing is a little bit off. That's fine. So that's my third harmonic, and then the way that the string moves is like this. So this is what the first three harmonics look like when both ends are closed, meaning both ends are nodes. Okay, this is a node. This point never moves. This point never moves. This is also a node. Now, the ends are not the only nodes. If you see here on the first harmonic, it includes no nodes between the two ends. The second harmonic includes one node, and that is right here. The third harmonic includes two nodes, one here, this point, and this point. So these are the nodes. You see one on the second harmonic, and you see two on the third harmonic. And as you can imagine, if you draw the fourth harmonic, you will see 3 nodes. If you draw the fifth harmonic, you will see 4 nodes, and so on. Now, there is something important that we need to know about the harmonics, the first few harmonics. So as I said, L is the length of the string. I need to know how to find the wavelength of my standing wave. So for the first harmonic, what do I see? I see the length of the string, L, and I need to think, what portion of the wavelength of the standing wave do I see here? Well, this is half of a wavelength, because the full wavelength would be going here and then come back. So this is half of the wavelength, which means solving for lambda will give me 2L. This is the wavelength of the first harmonic, 2L. For the second harmonic, I need to think, what portion of the wavelength do I have here? Well, I see that it's going up and then it's coming down at the same point. So I have exactly one wavelength. That means the length of the string is exactly equal to one wavelength. Okay, I'm done. For the third harmonic, I have the length of the string as usual. My string does not change. But now I see it's going up, it's coming back, and then I have another half of that. So I have 3 lambda over 2, which means the wavelength is 2L over 3. This is the wavelength of the third harmonic. And if you need to do the fourth one and the fifth one and so on, what I want you to do is to draw those harmonics and look at them, and you decide what portion what is the relationship between the length of the string and the wavelength. Okay, so I want you to have the ability, when you look at the standing wave, to know what is that relationship between the length and the wavelength. And this is the process that you can use to continue drawing the fourth and the fifth harmonic. Now, I do want to mention at the end, finally, repeat, in this case, I did the first few harmonics when both ends are closed. Okay, the harmonics will look different if I change this condition, and I will do that in a different video.